this video, we'll talk about storage devices used in computer. So in computer, basically there are two kinds of storage devices: primary storage device and secondary storage device. Primary storage device is basically a huge topic by itself. So today we will cover that in this video, and maybe in the upcoming videos we'll talk about the secondary storage devices. So in this video, we'll talk about the types of primary storage device, what is the purpose, and where and how it is being used in computers. So let's get started. So hi, we'll talk about storage devices. So what is storage devices? Storage devices is something that can store data or information in a device. Okay, that is a storage device, and it can be any kind of data or any kind of information ranging from video, audio, or anything. And what kind of storage devices can be? There can be any kind of storage devices like magnetic tapes, cloud, then optical discs, then there can be RAM, ROM. These are the primary storage devices, and all these are actually called as, in all, it is called as storage device, right? So we'll talk about, today in this video, we'll talk about primary storage device. So what are primary storage devices? Primary storage devices are basically divided into two categories: RAM and ROM. So RAM stands for random access memory. And ROM stands for read-only memory. Now first we'll understand what is the meaning of random access. Random access means that the memory that can be accessed from anywhere, or it is not serial, right? So for example, a DVD drive, when we play any song on the DVD, we are able to play any song from the list. We don't have to go serially. That is the case in which is the case in the tape. So earlier there used to be tape recorders, and that we used to insert those tape. In that tapes, we used to we can't seek over it. I mean, we have to play it serially, right? But that is not the case in DVD. So similarly, random access means which is accessible randomly. Now the second one is read-only. Read-only memory means that it is you won't be able to overwrite it, or it is written only once when it is manufactured. After that, it can't be rewritten or it can't be overridden. So there are special types in this also which can be written only once. So we'll talk about these things. So we'll first talk about random access memory. So random access memory is basically the place where we execute all our programs. So as we saw in the earlier video, we saw that our programs are bought into RAM, and there it is run. So any program can't be run on the secondary storage device. It has to bring or brought into the RAM for it to execute, right? So random access memory is basically the main memory of computer. Okay, this is called main memory. Now we'll try to understand what is memory. What is memory? Memory is basically, it is a free electronic space. So what is this free electronic space? This free electronic space is made up of multiple cells. So it's something like this. It has got multiple cells in it. This is one cell, second cell, third cell. So it is, all the collection of this is called as free electronic space. So this is a cell unit. So there are different types of cells. So this is cell. So there are two types of cells basically, SLC and MLC. So SLC stands for single level cell and MLC stands for multi-level cell. So single level cell will store 8 bits of data, 8 bit. So for example, English letter A can be stored in 8 bit of data, but the Hindi letter or this letter, Shri letter, can't be stored on 8 bits. It will require more memory to store. So it will get stored on multi-level cell, which is combination of two cells, that is in all 16 bits. So these are different kinds of cells in the memory system. Now we'll see characteristics of main memory or primary memory. So we'll see characteristics. What should main memory be like, right? So first is it should be either volatile or non-volatile. So what is the meaning of volatile? So volatile means that the contents of memory that will be there in memory until power is there. Once the power is lost, the data will be removed. So that is the meaning of volatile. So for example, RAM is volatile memory and non-volatile ROM is non-volatile memory. So even if the power is removed, the data still persists in the ROM. The second one is random or sequential. So RAM is random access, we saw that. And sequential example is tape recorder. So tape recorder is sequential. So in both places we are able to store the data, but in one of the storage device we are able to store the data sequentially, and other device we are able to store it and access it randomly. The next characteristic is it read write or is it read only? So read write memory is RAM and read only memory is ROM. These are the examples and the other one is characteristic. Fourth one is primary and secondary memory. Primary and secondary. So primary memory means that it has to do some vital functions, right? So for example, RAM is primary memory. So that means it has to execute the program in a really fast manner. And the other memory that is comparatively slower and its performance is low, but it is less expensive, and RAM is more expensive. Secondary memory like hard disk drive, PD drive, then magnetic tapes, all these are example of secondary memory, and all of them are less expensive but very slow in performance. RAM is more expensive but it's very high in performance. So there can be two things, either it can be primary or either it can be secondary. Fifth point is it can be either instruction store or data store. So it can either store instructions. For example, ROM is a memory that stores all the vital programs. Whenever a computer is manufactured, it has all the vital programs in the read-only memory. So this is the example of instruction store. And Data store all, like for example, all the um, video, audio, or anything that has that can be accessed in large chunks, or all of that, so our general data, so that can be stored on secondary memory, example hard disk drive, right? So these are the examples of instruction store and data store. So these are the basic characteristics of a memory. See, now we will, what are the types of RAM? So RAM is basically of two types, SRAM, and second one is DRAM. Okay. SRAM stands for static RAM, and DRAM stands for dynamic RAM. Static RAM is basically built of latches. Now, to explain latches, we need to understand what is a latch means, or what is the meaning of circuit. So, so it stores bit. We can say that it stores bits in the form of latch or a flip-flop. Okay. So store data until the power is there. Once the power is lost, the data gets lost. So we'll try to understand what is latch. What is the meaning of latch? I will explain a simple circuit diagram, explaining other circuit diagrams, or any is beyond this video. If anybody wants, we can go through it later on, but right now I'll explain a very basic circuit diagram, that is SR NOR latch. SR NOR latch. SR stands for set reset. So this is NOR gate. This is another NOR gate. And these are the two inputs. This is set input, this is reset input. Okay. And its output will go, so it will produce something output as Q and Q naught. So how it will produce Q and Q naught? If, for example, set is on, one is set. So if set is on, this output from reset will come and meet in this output, and this output from set will go and meet in this output. Okay, so reset and set. So if it is set, this is 1, and it is coming from here, so it is reset. So 1 and 0, which will make 0, it is Q naught, right? So we'll do this. If S or set is 1 and reset is 0, then answer will be set. If set is 0 and reset is 1, then answer will be reset. If set is 0 and reset is also 0, then answer will be hold. And set is 1 and reset is also 1, its output will be N. So for now, just remember this. We will have a separate video on the gates. Okay. So this is how a basic latch is formed. NOR latch, you can say. And using this, SRAM is built. So it stores the bit information in the form of latches. Okay. And what is DRAM? DRAM is basically a dynamic RAM. DRAM DRAM uses capacitor to store the data, and capacitor stores the electric charge. So for example, when a value is written to DRAM, the hardware charges or discharges the capacitor to store 0 or 1. DRAM loses its charge in a short time due to capacitor behavior, and it can be less than a second sometimes. So what happens in general computers, basically computer uses DRAMs contains the computer that uses DRAMs, it contains a extra hardware circuit known as a refresh circuit that performs the task of reading and writing a bit. So basically, if you are using DRAM, you need to know that there is always a refresh circuit present in the DRAM. And the diagram of DRAM circuit can be like this. So this is a circuit. For 1 bit, this is input, this is output, and this is another input known as write enable, and there is a circuit, that is refresh circuit. So it's like this, it continuously refreshes the DRAM to store the data. So that's what is about SRAM and DRAM. So SRAM is basically used for storing data in registers and in caches, and DRAM is used for storing data that is programs and all. So DRAM is actually very slow compared to static RAM. But as static RAM is very costly, we use DRAMs. As capacitors are low in price, we use DRAM for storing data in computers. Okay. Now we'll see what are the different types of static RAMs. So there are basically 4 kinds of static RAM. So first is cache RAM. Then there are CPU registers. Then there is DMA chip. DMA stands for direct memory access. And then there is flash. And these are all these static RAMs, and these are made up of the cells that I showed earlier. So each so you can have the density of static RAM by the count of cells that is there on it, right? So actually it's a cell count on the silicon chip. So it's kind of very costly, but it is very fast. So we'll see one by one what are the different types. Cache RAM. So cache RAM is basically kind of cache. So there are different levels in it. So for example, level 1 cache, level 2 cache, level 3 cache. So for a temporary purpose storage, this cache RAM is used. Then comes CPU registers. So CPU registers, there are different registers in CPU that are present for the various purposes, like general purpose register, and then ALU is also there in the CPU unit. So all these things are also made up of SRAM or type of SRAM. Then there is DMA chip. So a DMA chip is basically used for memory mapped IO or DMA or direct. So whatever the requirement of direct memory access is required, or input output access is required, so DMA chip is used for that purpose. Then comes flash. Flash is something that is used in both RAM and ROM. So flash drives are there, USB flash drives we have heard. So it is a type of both RAM as well as ROM. Okay. PROM. PROM stands for programmable ROM. Programmable ROM, that means a ROM or a device that can be reprogrammed. So that's why it is called as programmable ROM. Second one is EPROM. EPROM is erasable programmable ROM. So again there are two types of this, UV EPROM and EPROM. So this erasable EPROM needs to be erased completely. So yeah, it can be done, but it has to get erased completely to write it again. Then EEPROM, electrically EPROM. EEPROM is electrically PROM that can be erased partially and again rewritten. So these are the different types of ROM that are available. And then there is purely ROM, which cannot be erased at all, right? We saw that. Now I would like to enhance one point. So what is the difference between RAM and ROM? RAM and ROM. As we saw, RAM is volatile and ROM is non-volatile. How is it made volatile and non-volatile? So as we saw here, RAM uses these cells, right, to store data. Similarly, ROM also uses those cells to store data. Now the difference between those two is, now there is a separate link here. Okay, link cell is there. So in RAM these cells are present, and in ROM these cells are when the voltage, when the power goes off, these links are removed. Links are removed in RAM. But in ROM, these links are made permanent by using high power voltage, due to which it is able to store the data permanently. So that is the basic difference you can say between RAM and ROM, between being volatile and between being non-volatile. So according to me, this was it about today's video. So we saw different types of primary storage devices, what are its types, what are its characteristics, where it is being used, all these things we saw. In the next video we will see the secondary storage devices. So that is also a very huge topic. We'll try to cover that in the second video. We'll also go through different types of, as I told earlier, we'll also go through different types of gates, logic circuits if required, if anybody asks for it, or else there is a huge amount of things that needs to be covered. So till then, goodbye.